Hello, math magicians. Today's lesson is going to be on exponential growth. So let's jot down a few notes. All right, it's notes. Lesson 6.5. That's the section it matches up with in your textbook. And the topic, like I said, is exponential growth. Exponential growth. Alrighty. Okay, there is, let's see here, let's just kind of talk about exponential growth a little bit first. There's exponential growth. And versus exponential decay. So there's growth and there's decay. So in an exponential growth, when you graph it, the graph is going to be moving upwards at an exponential rate as you move from left to right. So it's going to be going up from left to right. And as you may be able to guess, in an exponential decay situation, it's going to go down from left to right. All right? So growth is going to go up as you move from the left to the right, and decay is going to go down or decrease. Increase as you go from left to right, decrease as you go from left to right. All right, today we're just focusing in on exponential growth, and we'll save decay for the next lesson. All right, before we really go into exponential growth, let's just remind ourselves about exponential functions in general. So let's just remind ourselves about exponential functions in general. And remember, they follow this formula. Y equals A times B to the X. And always, A is going to be the y-intercept. A will always end up being the y-intercept, miraculously. And B, let's call it the multiplier. It's what you multiply. It's what the y values get multiplied by every time as you increase 1 in the x values. Okay, now exponential growth is going to follow that basically, all right? So let's get specific now on exponential growth, which is the main topic of the day. Exponential growth is a special case of an exponential function. And here we go. It's going to be y equals A times the quantity 1 plus r raised to the t power. 1 plus r raised to the t power. All right. A, same thing. A and A. It's still going to be the y-intercept, but it's going to come from some story problems, and it's going to not only be the y-intercept, it's going to be your initial amount. It's what you're going to start out with, your initial amount. And that's the same thing as when we used to graph linear equations. Your y-intercept is where you started from, and then you started counting your slope. So A is still the y-intercept. And now, in a story problem, it's going to make a little more sense. It's going to be your initial amount. All right? Okay, this whole quantity here, this entire quantity, the entire quantity is called the growth factor. The growth factor. It used to be called the multiplier. Now it's the growth factor. But that makes sense. You're multiplying over and over and over, and so you will be growing. Okay? So you're multiplying over and over, and it's going to be a growth. So growth factor. Okay, the R, just the R. So the growth factor is the whole quantity. The R is called the growth rate. The growth rate, and that's going to be a percentage. Okay, that's going to come from a percentage. And then T is going to be the time. All right? A is the y-intercept. Yep, A is the initial amount. The y-intercept is where you start. B is what you multiply by. 1 plus R is how we're going to write the B, and it's the growth factor, what you're multiplying by, what you're growing by. R is the growth rate, which is going to be a percentage that you'll rewrite as a decimal. And instead of X, we're going to have T, which represents time. All right, let's try a problem or two. All right, let's try some examples. Okay, the first example, let's say you have $250 that you put in the bank, and you're saving it. You have it in your savings account. And your bank will pay you 4% annual compound interest. So the bank's going to pay you for your money. That's what interest is in this case. And they're going to pay you 4% compounded annually. And you're going to keep it in the bank, let's say, for 10 years. All right, this is going to be growth. The bank's paying you, so your money's going to grow. And it's compounding annually, so you can use the exponential growth formula. So here we go. Y equals A, and instead of B, we have 1 plus R. Instead of raised to the X, we have it raised to the T. And you just fill in, okay? So Y equals, A stands for the initial amount, which is 250. Initial amount is also the y-intercept. It's where you start. So 250 times 1 plus R. R is the rate, the growth rate, and the rate is the percentage. Now you don't write 4 here. You don't write 4%. You have to change that to a decimal. So that's 0.04. All right, so you have to write it as a decimal. And then T is instead of X, T stands for time. And we're talking 10 years. Okay, now you just do the math. Y equals 250. And then that's 1.04 raised to the 10th. So that's just like A and then B to the X. And now you just type this into your calculator. I would start here with my calculator because you need to do exponents first. So I type that into my calculator and then multiply it by 250. So 1.04 to the 10th power, then times 250. And it turns out to be approximately $370.06. And you should probably type it into your calculator to make sure that's the answer that you also get. And that would be the interest. That would be the interest that the bank is going to pay you for keeping the money in their bank. Okay, let's try one more. Okay, so here's our last example. Let's say that you had a 1938 comic book. So it's an old comic book. And the owner bought it for 55 bucks in 1980. So it was bought for $55 back in 1980. And then it was sold in 2005. And when it was sold, the value increased. Okay, let's be more specific here. All right, the value increased. So when it was sold, the value had increased at a 2.5% per year rate. 2.5% per year. So the value went up 2.5% every year. All right, let's give it a try. This is exponential growth, because the growth is a percentage per year, and it's growing, it's increasing. So we can use the exponential growth formula. Y equals A times the quantity, 1 plus R raised to the t power. So here we go. A stands for the initial amount. The initial amount was $55. We bought it for $55. And then 1 plus R is the percentage rate. Now remember, you don't write 2.5%. You have to change that to a decimal, so you have to move that decimal back 2 places. 0.025. So you have to change the percent to a decimal. And T stands for time. T stands for time. Well, how many years was it from 1980 all the way to 2005? This year doesn't really matter. Yeah, it's an old comic book, but we're only dealing with the money value changing or increasing right in here. We don't really know what it cost back then. We're dealing with from 1980 to 2005. That was, what, 25 years? So for 25 years, it increased. All right, here we go. Y equals 55 times 1.025 raised to the 25th power. Now you grab a calculator. You type this in, 1.025 to the 25th. Then you multiply by 55. And you should get $101.97. So you should double check. You should type it into a calculator and make sure that's what you get. So apparently in 2005, that's what the comic book sold for, because the price started at 55, but it increased that much every year. It increased 2.5% every year, which would get you up to $101.97. Okay, I hope this is helpful. Good luck with your homework. You might want to ask your parents about compound interest. Interesting conversation. You might learn something about investing. All right, good luck.